Mr. Clelland here for Clelland Maths. Today we're going to go through the whole of the sine rule for trigonometry and National 5 Maths. We'll define what the sine rule is, do a couple of examples, and then do every single past paper question. Just note this is closely related to bearings. Check the video up there if you want to go and check out my video on bearings, or there'll be a later one coming up real soon. Okay, so I've got a triangle here labelled A, B and C. So what is the sine rule at National 5 Maths? Well, first of all, we need to be able to label sides. A, B and C are capital letters. If we go from an angle and go straight opposite it, that side is also called A, but we write that as small. So that would be a little a there. And similarly, B would go down to here, so that would be a little b. And our C obviously is here, and that would be a little c. And all the sine rule is a formula which relates angles and sides as a ratio or a fraction. And the formula is this: A over sine A equals B over sine B equals C over sine C. So it is used when you're given a triangle, which is not right angled, but you can use it in a right angle triangle, any triangle this works for, to work out either a missing side or an angle. And what you need for it to happen is you need an angle in the opposite side, and then either you'll be finding an angle because you'll be given its opposite side, or you'll be finding a side because you'll be given its angle. Now what I don't want you to do is get hung up on the letters. A, B and C is for a triangle which is labelled A, B and C, but any triangle can be labelled with any letters you want. So what you really want to be thinking about is pairs instead. You want you want angle in opposite side, angle in opposite side. And you always need to have two pairs with one missing to find what it is. Let's do some examples. Example 1 says, calculate the length of AC. So we need to identify AC, there it is there, and we need to know the correct side that is. That's opposite this one, so that's my B. So we check the front of the exam paper to find the formula. And we'll always write that down first. A over sine A equals B over sine B equals C over sine C. And usually this is a calculator job unless they tell you the angle, the sine of the angle or something like that. So it is going to be a calculator job for this. But we look for pairs. So we've got A and A. So they go together. So I can just substitute in, I've got 8 centimetres for my little a over the sine of the angle, which is 45. This pair goes together, and this pair goes together, which is B over sine 85. Obviously I've not got C, so I just don't write that one down. It's always 2 pairs, even though the formula has 3 pairs. Okay, now we can rearrange this to work out B. Now there's a quick and easy way to rearrange this. If you just think, if it's fraction equals fraction, then you do top times bottom. So that is 8 sine 85 equals, and again, top times bottom. So that gives me B sine 45. So now it's quite easy to work out B on its own. I'm just taking the 8 sine 85 still, and you just divide by whatever's next to B above it, which is sine 45, so divide by sine 45. And we can do that all in one go in a calculator. So we get our calculator out, so making sure we use brackets so we get it all in one go. Bracket 8 times sine 85, and then notice my calculator, and what the calculator does is open a bracket for the angle. So I close the bracket for the angle, but then close the bracket for the sum. 8 sine 85 divided by sine 45, closing the angle for the bracket. If your calculator doesn't open an angle for brackets, then you can skip that step, but press equals and you get 11.270. 65, but I'll just put dot 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 instead of rounding it. And then you round it to a reasonable position, so maybe 11.3 centimetres, because the units were centimetres in the question. The second example of calculating a length with trigonometry using the sine rule, we've got this triangle labelled X, Y and Z, and it says calculate XY. So XY is along here, that's opposite this angle, so we could call that angle our Z, I suppose. And we also have this pair. So I check my start of exam paper and write down the formula, which says A over sine A equals B over sine B equals C over sine C. And now you've got two options. You can relabel your triangle ABC, or you can, if you prefer, which is what I do, is don't bother relabel it, just think of pairs. So I've got A and 30, so they go together, so that could be A and sine A. So I just write down A over sine 30. And then I'm looking for another pair of, I've got this one, not that one, because there's no number there, there's no angle. So it's this one and this one, so z over sine 50. And then we're good to go. We'll just do the same as we did last example. Top times bottom, so that's 8 sine 50 equals, and then top times bottom again, so that's z sine 30. Divide by the number next to z, that's at z equals 8 sine 50 divided by sine 30. Get a calculator to work that out. 8 sine 50, close the bracket for the angle and the sum, divided by sine 30, close the bracket, press equals 12.256 and a bunch of other numbers. So I always like 12.256. No rounding yet, so ... round that to somewhere reasonable, 12.3 units, centimetres, because it's a length and it was in centimetres. Example 3, calculate the size of angle A. So this time we've got a triangle, we have to calculate an angle, so we're going to use trigonometry and the sine rule for this. So let's just set this up. We've got this pair, so there's A and A. Let's call that little A just for the sake of it. And then we've got this one and this one. So we have got B and little b. Write down our formula. A over sine A equals B over sine B equals C over sine C. Substitute in what we've got in terms of pairs. So we have got 5 over sine A, because we have to calculate angle A. 5 over sine A equals, and then the other pair we've got is B over 85, so 6 over sine 85. Rearrange the same way we did before, so top times bottom. I just write down 5 sine 85 equals top times bottom, 6 sine A. So now sine A is what we're going to work out instead of A, and then we're going to use the inverse sine in the calculator. So sine A is equal to 5 sine 85 divided by the 6 in front. And now we can just write down that A is equal to the inverse sine of all of that, which is 5 sine 85 over 6. And when we get to a calculator, we've got two options. You can either work that out first and then do the inverse sine, or you can just do it in one go using brackets. It's your choice. So I press shift, usually up in the top corner, then sine, and that gives you the inverse sine, sine minus 1. And I'm doing 5 times sine 85, 5 sine 85, close the brackets for the angle, divided by 6. Close the brackets for the whole sum, press equals, and it says 56.115, and that's an angle. 56.115, or to a reasonable rounding, 56.1 would be fine, degrees. And we're done there. Example 4, calculating the size of angle X using trigonometry and the sine rule. So again, we have got a pair and we've got a pair, so I know it is the sine rule. So I write down the sine rule, A over sine A equals B over sine B equals C over sine C. And then we just work on our pairs, so we can just immediately substitute in. So we've got this pair, 10 over sine 126 then, equals this pair, 8 over sine X. And then we can rearrange in the normal way. Top times bottom equals top times bottom. So that's 10 sine X equals 8 sine 126. And now we just divide by 10 to find sine X. 8 sine 126, all divided by 10. So X is the inverse sine of that sum. 8 sine 126 divided by 10. Shift sine, make sure the bracket opens or open it yourself. 8 sine 126, close the bracket for the angle, and then divide by 10. And we get an answer, closing the bracket, of 40.331 or 40.3, and it's degrees because it's an angle. And we're done there. SBA National 5 Maths 2014 Paper 1 Question 5 on the sine rule. It says triangle KLM. KM is 18 centimetres. Well, it's there. It says the sine of K is 0.4 and the sine of L is 0.9. Let's take a note of that at its points. So sine K is over here, which is 0.4, and sine L is over here, which is 0.9. So this is a non-calculator question, so instead of telling you the angles, they've told you the sine of the angle, which means you can just use the number in the formula. But it is still the sine rule because you've got pair, angle inside, and pair, angle, and well, this side is LM. We have to calculate LM. So we have to do this one. So we write down the sine rule from the start of the exam paper. A over sine A equals B over sine B equals C over sine C. So then we've got our pairs, so we have got the side of 18 goes with sine L. So we can write 18 over sine L equals the other pair, which is sine K, and let's just call that K just to give it a letter. K over sine K. So we can then just sub in what we're given. So it tells us sine K is 0.4, so I don't need to work it out. And we know sine L is 0.9, so I can write 18 over sine L, which is 0.9, equals K over sine K, which is 0.4. Rearrange it in the normal way. So it's top times bottom equals top times bottom. So what does that give us? It gives us 18 times 0.4 equals 0.9 times K. So that means that rearranging that K is 18 times 0.4 divided by 0.9. And now it's a non-calculator job. So we need to do 18 divided by 0.9. Dividing by decimal is never any good, so instead we'll times the top and the bottom by 10 to get rid of the decimal. So that gives me 18 times 0.4 times 10 over 9. And now we can just do the sum. Now divide we can do instead of times first. 18 divided by 9 is 2. So that's 2 times 0.4 times 10. 2 times 4 then, because 0.4 times 10 is 4, which is 8. And the units were centimetres. And we're done there. 2017 Paper 2 Question 10. In the diagram below, D, E and F represent the positions of Dunbridge, Aylesford and Fairtown respectively. It tells us that Dunbridge is 15 kilometres east of Aylesford, and it's drawn it in for us. From Dunbridge, the bearing of Fairtown is 126, which is drawn not to here, all the way round, north, down to Fairtown. From Aylesford, the bearing of Fairtown is 230. From Aylesford, 230 to Fairtown. Calculate the distance between Dunbridge and Fairtown. Calculate this distance. Let's just mark that up there with an X. No other information given. So again, the strategy is the same as before. We're trying to find angles inside the triangle, so we can use the sine rule or the cosine rule. Let's just start on this bit here. You've got north and east. That's clearly a right angle, so I can write 90 degrees. And then angles around a point add up to 360. So I can do 230 plus 90, which is 320. Giving me 360 minus 320, which is 40 degrees. I can put 40 degrees inside this triangle there. On the other side, since it goes northeast, this bit also right here is 90 degrees. So that means these two add up to 126. So doing 126 minus 90, I get 36 degrees. So I've now got a second angle inside the triangle. Once I've got two angles inside the triangle, I may as well just find the third one, because chances are I'm going to have to use it. 36 plus 40, so let's just write that. 36 plus 40 is 76 degrees. 180 minus 76, because angles in a triangle add up to 180, gives us 104 degrees. So we can write that down here. And now we can check what it's asking us. We've to find a missing side. We've got one other missing side. So it's the sine rule, because for the cosine rule you would need this and this to get this. You've only got one side, so it must be the sine rule. So it's x over sine 40, opposites, x over sine 40 equals, and then the other side we've got is 15, and the opposite is 104. 15 over sine 104. A nice way to do this in your exam is to maybe get a different colour and just draw a line. These go together and these go together. Obviously they would go together as well, the other two, but I can't use them because I don't need that. So marks so far. You're getting a mark for 40 and 104 degrees. If you've managed to so far just calculate your angles inside your triangle, over here you've got a mark, and then you've got a mark for writing down the correct sine rule. Now we need to rearrange it. So as per usual, we can say that x sine 104 equals 15 sine 40. So x is still 15 sine 40, but then divided by the sine of 104 degrees. And that's a mark at that point as well. And then our final mark, of course, just for working that out in a calculator, 15 times sine 40, then divided by sine 104, you get an answer of 9.936. Or if you're rounding, 9.9 would be fine, and the units are still kilometres. Try not to forget your units. In National 5, there's one question where they will mark the units. They won't take marks off for forgetting the units in all questions, but there's one question you can never tell which one it's going to be, so just make sure you do your units. National 5 Maths 2018, Paper 2, Question 9 had this question. Angle ABD is 75 degrees, BDC is 37, BC is 20, calculate the length of DC, and we're assuming that this is a straight line, because otherwise we can't do it. So if this is a straight line, we'll start getting some angles inside. 180 minus 75 is 105 degrees. 20 over sine 37 equals, and it says calculate the length of DC, so that's here. So I'll just call that one B, because of the angle. B over sine 105. Once we get that far, then it's a case of just rearranging it. 20 times the sine of 105 equals B times the sine of 137. So dividing through by sine 37, B equals 20 sine 105 divided by sine 37 degrees. So now I just get a calculator and straight away work that one out. Get an answer for B of 32.1. Just check my units, centimetres. Now, National 5 Maths 2019, Paper 2, Question 19 had this long question. So it says, Katie and Mona are looking up at a hot air balloon. In the diagram below, K, M and B represent the positions of Katie, Mona and the balloon. So that'd be Katie, that'd be Mona, that'd be balloon. The angle of elevation of the balloon from Katie is 52, there it's shown there. The angle of elevation of the balloon from Mona is 34, there it's shown there. And the distance between Katie and Mona are 350. And it says, calculate the height of the hot air balloon above the ground. It's quite a hard question. It's why it's worth 5 marks. Notice, it's not asking me to calculate any of these diagonals. It wants me the direct height. So I can draw in a direct height here to show this, just by drawing a straight line down. And that's the side it wants me to calculate. Do not be tempted to think that cuts this line in half. It does not. So I'm going to need to get one of the other sides in order to use the sine rule or to use SOHCAHTOA to get the height. So that's exactly what I'm going to do. I'm going to start off by using the whole triangle to get one of the sides. You can pick any one you want, okay? I'm going to calculate this one, but you could go the other way and calculate this one. So let me draw a little diagram for us, or take some notes on this one. If I draw that without all the information, it's sometimes easy to do this. You've got 350 down here. I've got 34 degrees here, 52 degrees here, and I want to calculate this side here. I'll call that A. So I'll call that bit A. So I've got this pair, and I'll need another pair, but I've not got this one. So the first thing I'm going to have to do is get this angle at the top, because I need it to go with this one. So adding these two numbers together and taking away from 180. So 52 plus 34, that gives us 86. 180 minus 86 is 94, so I can note that is 94 degrees and start my work. Got A over sine 34 equals 350 over sine 94. And if you're going this route, you'll get a mark for that. We now need to rearrange that. So A sine 94 equals 350 sine 34. So A must equal 350 times the sine of 34 over the sine of 94. So getting a calculator and working that out, you get A is 196.195, or 196.2 would be fine, or even just 196. So far I've got 3 marks: substitution, rearranging, and getting an answer. But now I need to get the height, okay? So redrawing my triangle to side with all the information I've got now. I want this height here. I know that this bottom whole thing is 350. I've just calculated that this one is 196.2. And I know some angles. I know this is 52 degrees. This is 34 degrees. I'm not going to bother putting this on because it doesn't cut it in half. It adds up to 94, but it doesn't cut it in half. You can calculate either this angle or this angle using right angle triangles here. But there's lots of ways now to work out this height. The easiest way is to use the sine rule again. So we'll go ahead and do that. We have got, if I use a different colour, I'm going to use this one, goes with this one. And we're going to use this one, this is an angle B, goes with this one here. So we can just simply write A over sine 52 equals 196.2 over the sine of 90, because that's 90 degrees. Rearranging that, that implies that A times the sine of 90 equals 196.2 times the sine of 52. So A equals 196.2 times the sine of 52 divided by the sine of 90, which is 1, by the way. Just a note on this question: once you get to this point, that is a right angle triangle. You could have just used SOHCAHTOA to find A. I basically didn't, but I've just not bothered to do it for this question because SOHCAHTOA is a National 4 skill, but you might have forgotten. You don't need it at all in National 5. You can just keep using the sine rule. Just use the sine rule twice and realise that this angle is 90 and you'll be good. Okay, National 5 Maths 2022, Paper 2, question 14 had this question. Again, you can see it is made up of 2 triangles, so it's probably going to be double sine. That's how I remember this. If it's 2 triangles, most of the time it's double sine rule. And it's given us lots of information. Angle C is 28 degrees. Here, angle D is 12, that's here, and the distance from C to D is 15, which is here. BCD is a straight line. Calculate BC, the width of the river, which is here. So I've got only no real information in here. I'm going to have one side. For me to get this side, that goes with this angle, I need another side for this angle to work. So I'm going to have to either get this side or more easily get this side here. So we're going to look at this triangle here and get this side first. So I'm just going to label that side, well, that'll be D to go along with this D. Doesn't really matter. The most important thing is opposites attract. Now we need some angles first because we've only got this angle, but we're going to need this angle up here. So let's work on that Angles on a straight line add up to 180. So if I do 180 minus 28, that gives me 152. So I can note that here. 152 plus 12 is 164, leaving 16 degrees up here. So you had to do a little bit of angle work to get that 16, and now you've got opposites. That 16 degrees goes with that 15 meters, so I can say that 15 over sine 16 equals, and then that 12 goes with this d over sine 12. If you can get that far, you'll get a mark. Rearranging this, you get d sine 16 equals 15 times sine 12, so that d equals 15 times the sine of 12 over the sine of 16. If you can get that far, here's your second mark. And then you just type this into a calculator, 15 times sine 12 over sine 16, and you get an answer of 11.3. Our third mark. Now we go back and use that. So if I put 11.3 in, that's going to be here. Now this is starting to look really messy, so I'm just going to redraw this triangle. So the triangle we've got is here. I've got just worked out that this is 11.3. I know that I've got 28 degrees. And it's asking me to calculate BC, the width of the river. So it's this bit I want, so I'll just mark that on. So let's call this A and A. And then we could go B and B, C and C. So we're going to need to use these pairs with this pair. We don't know this angle, but we can work it out easy. 90 plus 28 is 118, is 62 degrees. A over sine 62 equals 11.3 over the sine of 90, and we're good to go. Or alternatively, you could use SOHCAHTOA and use sine or cos, but I prefer just to stick with the sine rule and keep going with there. So rearranging this, we get A times the sine of 90, which is 1, is 11.3 times the sine of 62. Rearranging that, you do 11.3 times the sine of 62. You go divide by the sine of 90, but that's just divided by 1. So it's just agree with doing this sum. If you do all that sum, you get 9.99 meters. And we're done for 5 marks. Looking at the sine rule first of all. So we're going to look at a few National 5 questions and get into it straight away. A set of step ladders has legs 150 by 140, SQA National 5 Maths 2016, Paper 2, Question 8. When the step ladder is fully open, the angle between the longer leg and the ground is 66. Calculate the angle X, which is shown here. So we really don't need this picture. So a reminder of the sine rule from the start of the exam paper, you get A over sine A equals B over sine B equals C over sine C. You can just copy that. And basically it's pairs. So if I call that letter A, that goes with this one, which is A. I could call that B, and that goes with this one, which is B. And obviously there's nothing on the other one, so I can just ignore them. So I've got A over sine A, 140 over sine 66, equals B over sine B, 150 over sine X. And you will get a mark for that substitution. You can now rearrange that to make sine X the subject. So I always think it was a cross. This times this, 140 sine X, equals this times this, 150 sine 66. So now dividing by 140, sine X is 150 times sine 66 over 140, and you would get a mark for that. And then your final mark for finding X. So you need to do the inverse sine, because they've got sine X, so X equals the inverse sine of 150 times sine 66 divided by 140. Now you can do all that in a calculator in one step. Press inverse sine, open a bracket, 150 times sine 66, divided by 140, close your bracket, and you will get an answer of 78.18 or 78.2 degrees. If you prefer, you can work out the answer to that first and then do the inverse sine of just that answer to get the same thing. Just make sure you don't round too early. SBA National 5 Maths 2021 Paper 2 Question 4 on the sine rule. Triangle PQR, it says PR is 11.3, QR is 9.8 and the angle QPR is 54. Calculate the acute angle PQR, which is up here. So it's angle Q we want. So we know it's the sine rule because we've got angle pair side and then angle side pair. So we can use the sine rule, just copying it at the start of the exam paper. A over sine A equals B over sine B equals C over sine C. And then just look for our pairs, not worrying about the letters so much. We've got this side goes with that angle, so I can just write 9.8 over sine 54. 9.8 over sine 54. And then the other pair we've got is 11.3 over sine Q. So rearranging this, top times bottom equals top times bottom. So I can write 9.8 sine Q equals 11.3 sine 54. Dividing then by 9.8 to get sine Q. 11.3 sine 54 over 9.8. Then Q is just the inverse sine of that sum, which is 11.3 sine 54 over 9.8. So we get our calculator to work out that. So the calculator, we press shift and sine, open the bracket, or it does it for us, 11.3 sine 54, close the bracket, divided by 9.8 and close the bracket for the sum. Gives us an acute angle, 68.88, so I'll just write that down. Or to one decimal place, 68.9 degrees, and we're done there. SBA National 5 Maths 2023 Paper 2 Question 4 on the sine rule. The diagram shows this triangle JKL. It tells you angle KJL is 25 as shown. JL is 10, KL is 7. Calculate the size of angle JKL. JKL, K is in the middle, J to K to L. This angle here is the one they want. So I know it's the sine rule again because of pairs. I've got angle, side, angle to find side. Two pairs means the sine rule. So I just go to the start of the exam paper and copy it down. A over sine A, it says, equals B over sine B, equals C over sine C. And then I don't get too hung up on the letters because I just know pairs go with pairs. So this pair, 7 over sine 25, equals the other pair, which is 10 over sine K. So then rearranging that, top times bottom equals top times bottom. So we've got 7 sine K equals 10 sine 25. So we divide through by 7. Sine K is equal to 10 sine 25 over 7, which means that K is equal to the inverse sine of all of that, 10 sine 25 over 7. And I usually like to do this straight away in the calculator. Shift, sine, open a bracket, 10 sine 25, close the bracket for the angle, divided by 7, close the bracket, 37.138. Or 37.1 degrees to one decimal place. And we're done there. This has been Clelland Maths today. We've went through the whole of the sine rule and trigonometry for National 5 Maths. Hopefully you found that useful, and if you did, give it a like and subscribe and give it a little thumbs up. Take care, stay safe, and goodbye.